Welcome to this three-dimensional cartoon classroom lesson on significant figures. Measurements are never infinitely precise. Every measuring instrument has a limited resolution, and every reported measurement contains some uncertainty. Significant figures provide a systematic method for showing the precision of a measured or calculated quantity. Significant figures are the digits in a number that carry meaningful information about its precision. They include all digits known with certainty, plus the first uncertain or estimated digit. For example, 12.4 centimeters has three significant figures, 1, 2, and 4. The first rule is straightforward. Every non-zero digit is significant. The digits from 1 to 9 are always counted as significant when they appear in a number. For example, 347 has three significant figures. 5.82 also has three significant figures. 26.491 has five significant figures. Zeros located between two non-zero digits are always significant. These zeros are sometimes called captive zeros. For example, 405 has three significant figures because the zero lies between 4 and 5. 7.008 has four significant figures, and 30.04 also has four. Zeros appearing before the first non-zero digit are not significant. These leading zeros only show the position of the decimal point. For example, 0.0045 has two significant figures, 4 and 5. 0.000720 has three significant figures, 7, 2, and the final zero. Zeros written at the end of a decimal number are significant. They indicate measured precision. For example, 2.50 has three significant figures. The final zero shows that the value has been measured to the hundredths place. 0.4800 has four significant figures, and 12.000 has five. Trailing zeros in whole numbers without a decimal point may be ambiguous. The number 1500 could have 2, 3, or 4 significant figures depending on the intended precision. Scientific notation removes this ambiguity. 1.5 times 10 to the power 3 has two significant figures. 1.50 times 10 to the power 3 has 3. 1.500 times 10 to the power 3 has 4. Exact numbers are not limited by significant figures. An exact number may arise from counting, or from a defined conversion. If a classroom contains exactly 20 chairs, that number is exact. Also, 1 meter equals 100 centimeters, and 1 minute equals 60 seconds are defined conversions. To round a number to a specified number of significant figures, first locate the required significant digit. Then examine the digit immediately to its right. If the next digit is less than 5, leave the required digit unchanged. If the next digit is 5 or greater, increase the required digit by 1. For example, 7.8432 rounded to three significant figures is 7.84. For multiplication and division, the final answer must contain the same number of significant figures as the quantity with the fewest significant figures. For example, 2.4 times 3.16 equals 7.584. Since 2.4 has only two significant figures, the final answer is 7.6. Similarly, 12.5 divided by 4.2 is rounded to 3.0. For addition and subtraction, the rule is different. The final answer must be rounded to the same decimal place as the least precise quantity. For example, 12.45 plus 3.2 equals 15.65. The second number is precise only to the tenth place, so the final answer is 15.7. Similarly, 25.6 minus 2.34 becomes 23.3. Common mistakes should be avoided. One mistake is counting leading zeros as significant. For example, 0.0032 has two significant figures, not 4. Another mistake is assuming every zero is insignificant. 4.00 has 3 significant figures because the trailing zeros show precision. A final mistake is rounding too early in a calculation. Rounding should normally be done at the end. Significant figures indicate the precision of measured quantities. All non-zero digits are significant. Zeros between non-zero digits are significant. Leading zeros are not significant, while trailing zeros after a decimal point are significant. For multiplication and division, the result is limited by the fewest significant figures. For addition and subtraction, the result is limited by the least precise decimal place. Correct use of significant figures ensures that calculated answers do not claim more precision than the measurements justify. Thank you for watching.